All right, let's solve for x. Using log properties, power properties, quotient properties, whatever, we have to solve for x. They're inside a log and they're all over the place. Now I know some of you might look at this problem and say, ha, I know what I'm going to do. I'm going to put a big 5 here, I'm going to put a big 5 here, and I'm going to put a big 5 there and blow up those logs and make these cancel and all that. You cannot do that. The reason why you cannot do that is because that plus sign right there is a big stopper. The undoing of addition is not done with exponentials, so you cannot mathematically give the base 5 exponential to each of these logs when they're split up by plus. That doesn't work because the opposite of addition is not exponentials. So that is not allowed, so we can't do that, so we have to get that out of there. So that's not going to work. Instead, what's going to work is if I can combine these two to one log, then if I have one log equaling another, then I can blow that up with a big 5. So that's what I'm going to do. I'm going to use the condensing idea to multiply these two things together with this log base 5 equals log base 5 of the 2x plus 24. And now I've got log base 5 equals log base 5. Well, now I can get rid of that log base 5 by putting a big 5 on it, and then they would cancel equally, and I'm down to what was just in there. So on this side I'd have x minus 3 times x minus 2. On the other side I'd have 2x plus 24. Now, this is one of those where you better know your math because you got to square that, and then you're going to have an x squared, which leads to quadratic formula. So if I multiply these two together, if you don't know how to multiply these two together, you can do x minus 3 over here, x minus 2 over here, fill in the boxes and find it. I just happen to know that that's x squared minus 5x plus 6, and then that equals 2x plus 24. Bring all that over by subtracting 2x and 24, and then this side would then be 0 is just a number, which I want because then I can use quad form, and then I get x squared minus 7x minus 18. Run the numbers on this with quadratic formula or graph it and look for the x-intercepts. You're going to notice that x equals 9 and negative 2. Now, what you need to be careful of is the fact that one of these is positive and one of these is negative, and you have to look and see if it makes any of these logs negative, because the moment that it makes one of those logs negative, you're going to end up getting a non-real answer. So if you were to take and plug in one of those numbers into your calculator where you had like that first part where it says x minus 3, if I put negative 2 in there, I would have negative 5 in there. And so what you would end up with is you would have this. You'd have log base 5 and negative 5. When I do that, it says, oops, non-real answer. So what that does is it makes this part right here, if I put that in there, it makes that part negative, which then turns this into a non-real. Well, it's an imaginary. And then this part's also imaginary because that becomes negative also. But this one stays positive because when I put it there, 2 times negative 2 is negative 4, plus 24 is 20. This makes a real. When does an imaginary equal a real? Never. So that answer does not work. It's a non-real answer. This one is extraneous. It does not work. The only correct answer to this is x equals 9. Any of them that produce a negative in one of these substitution spots have to go. They cannot work. They are not allowed. When I put the 9 in, this stays positive because 9 minus 3 is 6. When I put the 9 in there, it stays 7. When I put the 9 in there, it's just a big number, so we're okay. 9 works. Negative 2 does not.